Okay, so now we have done use the pressure at a depth. Now let us see what is the atmosphere, what is the pressure at certain height h above the earth surface, above this level of the above the sea level. So let's say you like to find I give you, this is any hill and this is the sea level. This is the sea level. The height of this hill is, let's say let's say this is Shillong. Let us find out what is the atmosphere acting roughly, approximately what is the atmosphere acting over us. No, I'll give that for you to try. Let us take this as 1500 meter. Let's say this is 500 meter, the hill is 500 meter above the sea level. Then how will you find the atmosphere, how will you find the pressure acting here? So we know, so we will consider here density of air which is decreasing as you go up, but we will consider to be constant. Density of air to be constant, otherwise it is decreasing, it is exponentially decreasing. So we will not do that. We will consider the density of air to be 1.27 kg per meter cube. Remember, it's not gram, kg per meter cube. So we need to find out what is the pressure. Find the pressure acting at the top of the mountain. So how will you do this? So this is the pressure here. This is the, so here this is the pressure at the bottom, this is the pressure at the top, and this is H. So in this case what you have to do is this, pressure at the bottom, as you know, is equal to pressure at the top plus H rho g. But here pressure at the bottom is the atmospheric pressure and the top one is what you need to find. So pressure at the top will be pressure at the bottom minus H rho g. Therefore pressure at the bottom is atmospheric pressure, which is PA minus H rho g. So that should give me 101,300 minus 10 into density of air is 1.27 into G is 10. So if we do that, 100 cancel 127, you can see almost neglected, almost very less. So it is 101,300. if you subtract minus 127, so it is almost 101,300 minus 127. If you do, I get this as approximately 101 127. Let me just take 100 only. So I'll get this as approximately 200, little less. So this is the pressure at the top. This is the pressure acting at the top, Pascal.
So why have you taken the height 10?
Oh, I should have taken 500 meter. I'm very sorry. Anyway, I explained to you that, yeah, I'm very sorry. It should be 500 meters. So 500 into, same way, 1.27 into 10. So if I solve this, I should get here 1.27 into 500 into 10. I get this as around 950 Pascal. 950 Pascal. This is the pressure acting at the top. Now let me give you for you to try it out. So let me give you two homework which you can try it on your own. First is, considering all this question, you will consider the density of air to be constant, which is not. So, but still you consider the air density to be constant. Find the pressure find the absolute pressure. These are called absolute pressure on the Mount Everest. Please excuse my sentence framing. Mount Everest, height of Mount Everest is 8,846 or 45 meter. I think it's 40. Let us take this as 50 meter. I am not sure about it. 8,840 meter. Next question. As we are resident of Shillong, height of Shillong is 1400 meter compared to this. Now also find, let me give it a second question. Also determine the absolute pressure acting on the citizens of Shillong. Height approximately 1400 meter. Compare these two. Compare it where the pressure is. Compare it with the Mount Everest. Compare with the pressure at Mount Everest. Okay. So these are the two questions which you can try it out. Next, what we'll do, we'll do now something called so we have learned Pascal's law. Let us see what the Pascal's law is applied. So according to Pascal's law, which I taught you in the beginning, is that according to Pascal's law, the pressure given to an incompressible liquid is equally distributed throughout its in all direction. So this was Pascal's law. So let us see this effect. Means, what does this mean is that if you are giving here P1, this is P2, this is P3, this is P4, you will see that P1 would be equals to P2 equals to P3 equals to P4. All of them will be equal. So what are its applications? Let us see. Let us come to hydraulic lift, an example of Pascal's principle. Hydraulic lift, an application of Pascal's principle. You must have seen that when you go to a car mechanic, one very common thing they will do when they want to lift the car, they have a flat base like this. There is another one. There is a flat base here which is fitted with a piston. There is a small piston, there is a big piston like this. Okay, so these are some pistons. These pistons are fitted with two big cylinders like this, and here what we will see is these pistons carry these pistons. Okay, we will not show separately. What we're going to show here, it is filled with oil of certain density. Now I am showing you the principle. Here, if we give the cross-sectional area of this piston is, the cross-section of this piston is A1, and for this one is, let's say, okay, let me take this as A2, let me take this one as A1. This is A1. This is A1 and this is A2. You are applying a force F1 here. This is a simple piston, nothing else. Piston means this is a cylindrical chamber in which you have fitted with some kind of solid circular metal cylinder, which can move freely between this chamber, and as a result, what will happen? Using Pascal's law, what we can say is that as you push this, then what will happen? The pressure this side and the pressure that side will be same. Okay, so Pascal's law says that pressure 1, that is P1, will be equal to P2, because pressure given in one side will be equally distributed everywhere. So P1 is this side and P2 is this way. This is the bigger piston, this is smaller piston. So if I keep a hard load here, little bit of push this side will also, can we see like this, F1 by A1 would be equal to F2 by A2. So if you see, if F1, so what we can write, F2 can be written as F1 by A1 into A2. So if you look, if the cross-sectional area is large in this side and the area 1 is small, if area 1 is small, and so if this is small, area is small, this force is large, you are getting a large force. Similarly, if you are keeping area 1 as constant, you can also see that how this F2, the force F1, is getting amplified. So little bit of push here, you can lift a heavy load on the other side. This is based on Pascal's principle. Let us see what does this mean. Let us see this thing with an example. A hydraulic lift is lifting a car of 2000 kg, at its one end, one cylinder, what is the force applied by a person if the cylinder areas are cylinder diameters are, so D1 would be the one with the smaller piston. D smaller piston, I write this as D small, is, let's say, 4 meter, no, 2 meter. 2 meter is too much. 1 meter. And D large cylinder would be, big cylinder will be, let's say it is 4 meter. 4 meter diameter. How will you do this? So this is the picture given to you. You have a very small cylinder which is filled with oil. Both sides is filled with oil. Now, oil is an incompressible liquid. So when you apply a force here, the pressure is equally transmitted to the other side. And consequently, what will happen now? This thing will get lifted. Here we have placed a car of how much weight? 2000 Newton, 2000 kg. So what is this F1 we need to find? So 2000 kg means F2 must be equal to 2000 into 10. That means 20,000 Newton. 20,000 Newton is on the F2. What is F1 is that we need to find out. So we know, using Pascal's principle, F1 by A1 should be equal to F2 by A2. Implies F1 is, I need to find, F2 is 20,000 divided by area. So pi, here you can see what you can do here. One interesting thing, I will show you this side. F1 by F2 can be written as A1 by A2. So here pi R1 square by pi R2 square. So you can clearly remove pi. So this equation can also be written as F1 by R1 is equal to F2 by R2. So we can employ this thing here. So F1 by, so diameter would be 1 meter, that means 0.5 meter, half meter. So F1 by 4 would be 2 into half. So that means 4. So 20,000 divided by 4, that gives me 5,000 Newton. So 5,000 Newton is the force applied. That means 5,000 Newton, remove 10, around 500 kg force. So if you remove this, so how much mass of force you need to apply? So if I remove 10 from here, so mass would be 500 Newton divided by 10. If I do, it gives me 500 kg. That means you need to apply a force of equal to 500 kg on this side. So if you place a 500 kg mass there, the car will get lifted. Car will get hosted. But how much will it move? Let us see. So how much lift can you go? How much displacement is this? You see, it will get lifted, right? So how much lift is this? We need to see this. Let us see how we can do that. So to find out, we need to see the work done. How do you find out the work done? And then how you can calculate, how can you calculate the displacement done? Okay. So what we can do, work done in hydraulic lift. Hydraulic lift. So you see the work done in hydraulic lift is kept very small. That is the displacement of the cylinders are very small as we can do. It is always tried to keep the area cylinders are kept very small, not large. No large displacement is taken. It has been taken. The cylinder on the one end slowly comes down, and the cylinder on the other side also slowly goes up. No rush in it. Okay. Yes, we can do, but the displacement we have to keep it in such a way the work done is not got wasted, or work done is same. Right now we learn like that way only. Other factors is involved, but we'll learn. So what we can do, what we can understand that the input work should be equal to output work. So what is the input work? Input work would be F1 D1 and output work should be equal to F2 D2. So you can see we can easily calculate F1 by F2 should be equal to D2 by D1. So knowing F1 by F2 we can easily calculate D2 by D1. What is how much the cylinder has removed, how much the cylinder has displaced. If this much has been replaced by, so note here F is inversely proportional to D. Correct. That means if this is our curve, inversely proportional. So as the displacement is large, force will be less. And if the force is very large, displacement will also be if the force is large, displacement will be less, and so on. So this is how we can see the work done is conserved. We have to make a system that there is no loss in the energy takes place while do that. So we try to keep it small as possible. So then we can easily frame a question regarding this. For example, let us see. If I give you the same hydraulic lift, I give you here. Here is another hydraulic, the bigger cylinder. Let's say this is this cylinder is, this one's diameter is 10 centimeter and this is 2 meter. We need to find out if a force of 5 Newton is applied this side. I apply a force of 5 Newton. We need to find out how much can it lift. This hydraulic lift or hydraulic mechanism, how much can it lift on the other side. And doing so, if this piston make a displacement of 5 centimeter, how much does this bigger cylinder goes by? What is the displacement of? So what is D2 is you need to find out. How much does the second cylinder get displaced? By how much amount the bigger cylinder will get displaced. Let's see. So to do that, the bigger piston get displaced. So you need to do that. First, using Pascal's law, what we can say F1 by A1 is equal to F2 by A2. So F1 by F2, I need it. So F1 by F2 will give me A1 by A2, which you can also write this as diameter R1 by R2, R1 by R2. So what is R1 in this case? R1 in this case would be 25, 5 centimeter. So 5 into 10 to the power minus 2, and R2 would be 2 meters. So that means 1. That means F1 by F2 is coming to as 5 into 10 to the power minus 2. Now F1 I know, 5 Newton. So what would be F2? So F2 will give me F1 by 5 into 10 to the power minus 2. So F1 is 5 Newton. 5 by 5 into 10 to the power minus 2. That gives me 100. 100 Newton. So you see how much is the amplification ratio. You can easily find out. So if you see F2 by F1, so percentage, how much is the increase in percentage? Into 100. If you see the output ratio, the ratio is, or efficiency is 100 by 5 into 100. So that gives me 20, right? So 5, yeah, 20. So 20 into 100, 2000. Almost 2000% is the ratio, if I am not mistaken. F2 is 100 and you have given 5, yeah. So 5, 2 is 10, yeah, 20, yeah. 2000% is the increment, is the efficiency. Now, how much displacement does it move? Now, it is given, we know the work done is been kept as small as possible. So, work done is not lost, considering the system to be ideal. The energy is not lost in the system at all. In that case, if the energy is not lost at all, then we can say input power is equal to output, input work is equal to output work. So input work will be how much? Then force into 5, F1 into D1 equals to F2 into D2. So F1 by F2, how much we know? 5 into, so D1 is given to as 5 centimeter. So F1 by F2 is equal to D2 by D1. So F1 by F2, we know this as 5 into 10 to the power minus 10, minus 2, and D2 is, the displacement is what I need to find. This is not the diameter, this is this displacement, vertical displacement, how much? And D1 is how much? 5 centimeter. So 5 into 10 to the power minus 2, that gives me, D2 is giving me 25 into 10 to the power minus 4. Look, 25 into minus 4 means 25 into 10 to the power minus 4. How much meter is this? That means 25, 0.0025. D2 is getting displaced by only 0.0025 meters. So you have been able to lift only little bit. You have been able to lift this vehicle by little bit distance, not much. So you have to displace this cylinder a lot to increment, to take it up to a significant amount of distance. This is what we want to show you here. Okay, so as an example, we can go to hydraulic lift. If I take you to hydraulic lift, what happened, is not working. Okay, I'll show you. Let us go to the desktop. Hydraulic lift. So we can see this. No, 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 no. No, not like that. They are showing you the products. You do not need to see the product. We like to see. Here is the actual functioning. This is not the actual function. This is the more high-end functioning of hydraulic. But we will see hydraulic principle here. What about jack and all? You see, okay. This is an hydraulic jack, same way it works, but no. Do not need to see that. Hydraulic. We go to wiki. So what do I mean is, no, we don't have much here. Just a minute. So we can understand through this equation, this one also. As you can see here, this is the normal hydraulic which you see present in this heavy lifters, no, JCVs. You must have seen these JCVs. Here we can see, I can see two cylinders here, and there is a fluid. Okay, incompressible fluid is present, where when you give pressure to one cylinder, the other can be lifted. Okay, these are so many other factors there. The underlying principle is what you have learned today. That I can see here one fluid present here, and this is a cylinder which can come in and come out. These are the chambers, these are the tube through which the liquid is going to come from the other end, from the other cylinder to here, and it is going to gradually lift it. And as it lifted, the hinge, this hinge, wherever it is connected, it will perform work. This is the portion where the fluid is gradually coming and is growing. Okay, it will either increment or decrement. You can see an example of hydraulic would be hydraulic arm. Hydraulic arm. So hydraulic, you see people have made this. You can see in the YouTube video. This was very popular. You can see in the hydraulic arm they are using. You can see in this picture that 4 syringes has been used, and along fitted with a 4 other syringes at the different portion of the arm. Now as you place this, let us go and check the video. This one probably the demonstration here.
Need a professional logo for your brand? I used the new Wix logo maker to create one for my startup. I'll show you how.
See? Okay? So this is how it is going to work. No, they are showing you how to perform this. This is a very old project nowadays. Everyone makes it. C is functioning. You can go through this video and learn how to do it. I hope you understood the underlying principle regarding the hydraulic lift. This is how it works. This is just water only. Don't expect these are any kind of liquid or oil. No, this is just water, nothing else. It just made some color has been made to make it look good. That's it. This is the principle, basic principle of a hydraulic lift.